Hello again. This is our video solution to problem 2C from Superquiz 2. Final antiderivative here, and there's no fraction, so definitely, right, we're looking at using integration by parts. And it's a little weird, right? We write this thing down. We're looking for an antiderivative of arctan. And if we're going to use parts, like where are the parts, right? There's just like the one piece. I thought you're supposed to use integration by parts when it was for, something like the product rule. But there's actually this special case that's really, really nice. Integration by parts is very useful when you know how to differentiate a function and aren't sure how to antidifferentiate it. And as we saw in problem 2b, where we know an antiderivative, or a derivative for arctangent, right? We know that the derivative of arctangent is 1 over 1 plus t squared, right? Or 1 over t squared plus 1, right? Your call as to how you want to write it. So when we use integration by parts, okay, I'm going to actually use the tabular method with boxes here. I'm going to make my u, right, the thing I'm going to differentiate, the arctan, because I know how to differentiate that. And the other bit, the dv, will just be the dt, of course, and we just denote that with a 1. Okay, so I take a derivative, and I get 1 over t squared plus 1. I take an antiderivative, and I get a t. Now at this point, this is where I go into the box. Okay, so remember, inside the box, it just means I'm redistributing things, right? I'm just rearranging them. And so the first thing I'd like to do is take this t squared plus 1, which is in the denominator, and move it over to the right. So I'd have 1, and then I'd have t over t squared plus 1. Okay, note, it doesn't change anything as long as the product remains the same. Okay, now in the next step, I would want to take an antiderivative on the right and a derivative on the left. To take this antiderivative, man, I really wish this was a 2. Right? Like a 2t, because then I could use substitution. Oh, wait a second. What if I just put a 2 here? You think anybody would catch it? Hey, it's cheating, all right? You can't cheat forever, but I can fix it because I'll just divide by 2 on the left. All right, I have a half here, I got a 2 there. The product didn't change. So when I take a derivative of a half, it's 0. When I take an antiderivative, this is going to be the natural log of, well, I should say absolute value of t squared plus 1, but that's actually that's actually a positive function, so I don't even need absolute values. Okay, so substitution here on the bottom would just turn this into a 1 over u, right? So that's why I get this. Okay, I draw my lines, never lines inside the box, because you're not doing integration by parts inside the box. All right, only outside the box. And so my antiderivative will be t arctan of t minus a half the natural log of t squared plus 1.